Welcome to Ag Tech Talk by AgriBusiness Global, where we explore the cutting-edge technologies and global crop protection industry. I'm your host, Lauren Milligan, content specialist for AgriBusiness Global. Today's episode of Ag Tech Talk by AgriBusiness Global, I am joined by Dr. Michael Strano. Thanks so much for joining us today. I understand you're in Singapore right now.
Thank you. Yes, I am. Sunny Singapore.
Do you want to tell us a little bit about what you're working on and why you're in Singapore right now?
Right. So Singapore wants to produce 30% of its nutritional goals by 2030 domestically. So Singapore is an island nation. It's actually has a very high population density. It's about Manhattan, if you want to think about it like that. It wants to secure itself from fluctuating supply chains. And so it's trying to grow its own food domestically. And of course, it has to do that by urban farming. And so it's investing in a number of technologies that can, what are called controlled environment farming, where you can produce food with many harvest cycles per year. Sometimes you're adding sunlight from electricity off the grid. You're adding water, sometimes to rooftop farm. There's lots of different farming models. And what we're doing, I'm part of MIT's SMART program. SMART stands for Singapore MIT Alliance for Research and Technology, SMART. It's MIT's research enterprise in Singapore. And I lead an integrated research group, sort of an academic center that's focused on agriculture. It's called DiSTAP. And your listeners can go to distap.mit.edu. They can find out more about it. But it's a satellite lab in Singapore where we're trying to develop technology that can get information from living crops and plants to farmers much faster than is possible now. And we're doing that by making new technologies that tap into the internal signaling of a living plant and can get information about the stresses that it's experiencing, its responses to growth conditions, pathogens, biological stress. And the idea here, or the selling point, is farmers, I know you're part of AgriBusiness Global. Farmers have been able, for maybe 1,000 years at least, they've been able to look at their crops, look at leaves, look at the morphology of the plant, and they can diagnose maybe nitrogen deficiency or improper watering or plant diseases. All of that information comes much too late. So even what are considered early markers, water stress in plants, come way too late. So a lot of precision agriculture is just making up for last year. It's where to deposit seeds, where there's more productivity. So to break out of that, we need tools that can harvest information from the plant fast enough to where farmers can make decisions. And that requires a really new set of tools. It means going into the quote unquote nervous system of the plant. Living plants, they don't have nerves like humans do, like nerve endings or nerve cells. They do have a quote unquote nervous system, though. It's just decentralized. And they communicate throughout the plant through chemical signaling. And so at DiSTAP, we're making technologies that can intercept those signals and send them to your cell phone and allow the farmer to make decisions, and researchers. So it's really our stakeholders are farmers, engineers, agribusiness technology researchers. So I'll pause there.
Well, that's pretty amazing. Can you tell me a bit about what role will real-time non-invasive plant monitoring play in the future of precision agriculture? I feel like that's kind of a good segue into my first question.
Well, the dream that everybody has is that you could use real-time feedback from a plant. Say, is the plant growing? For that, you might want to monitor a hormone called auxin. So plants will express auxin, and the gradient literally tells the plant the direction to grow in. If you can tap that, then you can know right away if a plant is happy and it wants to grow. And I think the dream is to be able to place living crops in a controlled environment and then tune these knobs. Like imagine the amount of light, even the color or wavelength of light, the intensity, water, carbon dioxide, nutrients in the soil. Imagine those as knobs. And if you tune them to the right amount, you'll get the optimal growth. And so the dream has always been you could have sensors informing how to turn those knobs in what's called a control loop. And there are a lot of advantages to that. You could optimize growth, but you could do so really for any seed or really even any crop. So imagine a farm with a very rapid harvest cycle. You get many, many harvests per year, but you can drop in seeds from all over the world. You can even change different crops. You can grow strawberry, you grow green leafy vegetables, and you just drop it in, it'll automatically be the growth environment will automatically be optimized in real time, responding to diseases and stress. So that's the dream. We're taking a step back. In order to have that dream, we need to get information from crops fast enough. We need to get it fast enough for at least a farmer to intervene, and then at some point a computer or AI control to intervene.
So, how can advances in plant hormone detection reshape crop breeding and development strategies?
Well, crop breeding is interesting. Crop breeding, so you mean generating new crops, phenotypes, or marker-assisted breeding? Well, hormones contain a lot of information about how the plant is responding to its environment and how it plans to launch future responses. So you could screen seedlings for certain sensitivities or not sensitivities to plants. There are plant behaviors we would like to suppress. There are other plant behaviors that we'd like to promote. One example that we'd like to suppress is called shade avoidance syndrome. It's if you, some of your listeners might know about it, if you plant crops too closely together, they will shade each other. And it's not in itself a problem, but actually there's an evolutionarily conserved mechanism where plants will try to race above the canopy in a last-ditch effort to shade their competitor. And what they do is they put a lot of the biomass into very low value, say long stalks. And this shade avoidance is not needed, but the plant will do it. If you can suppress it, you'll increase biomass and you'll be able to plant plants closer. And so shade avoidance syndrome occurs when a plant receives an imbalance between red and infrared light. And it uses that as a signal saying, oh, I'm being shaded by other plants. It's mediated by a series of hormone signaling pathways. And if you can measure those, you can intercept them, you can even select against or inhibit them, then you can remove this trait, which turns out to be very deleterious. That's one example. Probably dozens and dozens of other example targets there.
What are the potential barriers to scaling high tech plant sensors from lab research to field deployment?
Well, it depends on the kind of farm, and it's not being ambiguous about it. But when it comes to controlled environment farming, there really is a spectrum. There's everything from really low tech. So think about your community farm or a rooftop farm. You're still getting water and sunlight from the environment. Those farms operate and they have very little bandwidth to use sensors. They have to be extremely cheap and affordable and so forth. All the way to up at the higher end is really highly roboticized farms where it's a controlled environment. There's a favorite, if any of your readers are familiar with a clean room, that's a model where you sort of go into a clean room like a semiconductor fab, but you're growing plants. Everything is very automated. All the energy comes in, water comes in, the environment is controlled, and you try to make up for it with volume, many growth cycles. So there's not one size tool that fits all of them. And what we're trying to do in DiSTAP is meet different producers where they are. Some with, say, medium to low tech, others very, very high tech, but need very high capability, right? And then others are more on the research side, doing that plant breeding that you talked about, and they need a different set of tools.
How might the convergence of biotechnology and nanotechnology revolutionize crop management systems?
Well, really, you need to have a symposium. Actually, I just came back from a plant nanotechnology symposium in Poland. The local university there has a department of plant nanotechnology. To just give a survey of the field, you're seeing a lot of effort in using nanosystems to deliver genetic material to plants for plant transformations, for using, say, CRISPR-Cas9, and that's having a fairly significant impact. So new tools for genetically engineering plants. You're seeing nanofertilizers, so using the ability for nanoparticles to cross biological membranes, they can enter the root structure, they can exist in the rhizosphere, and they can be brought up into the plant. So nanofertilizers that are targeted may solve the problem with soil-based farming. The statistics people use, there's 90% of fertilizer runoff. So, you fertilize, but really only say 10% is getting to the plant. The rest is wasted. It's a big expense. but it's also going off and it's fertilizing things in the environment that we don't want. It's going into rivers. So nanofertilizers have a potential to reduce costs, but also prevent this environmental impact. You're seeing a lot of work in sensors. That's what we're doing. I think the field is gaining an ability to measure things in plants in real time, inexpensively. The hope is to bring those tools to farmers and to an increasing sphere of stakeholders. You have a growing field of making nanoparticles that are naturally derived. So even derived from the plant itself. These are particles, they can be food additives. They're nanoparticles made from biological or sometimes biodegradable. There are new technologies that are delivering things into plants that can enhance, they can enhance nutrition. So I have a colleague in DiSTAP who's done some pioneering work there. You can deliver plant hormones, you can change the shelf life of plants. So yeah, and hopefully that was a good survey. I mean, I don't know. I feel like I could bring dozens of my colleagues in and they could do a better job of explaining where the field is.
No, that's amazing. Do you think innovations like smarts nanosensors can help bridge the gap between food security and sustainability?
Well, food security, yeah. So is there a gap between food security and sustainability? Yeah, so sustainability in agriculture, I tend to think of as a nexus of waste management, trying to utilize less water, trying to manage resources that go into farming, especially if you're going to move indoors, you're going to use more resources for growth. So how do you manage that? And I think that's where sensors can come in. You get food security through growing indoors in a controlled environment, but then there's an increase demand on the grid and water. Sensors, if used correctly, can try to minimize that impact. There are trade-offs, so of course, there's not much you can do about that.
What kinds of partnerships and investments are needed to bring next gen plant health tools to the global markets?
Well, I think what we're finding is that there's no one size fits all tool, and farming is diverse as the different regions around the world. So I think that there should be more investments. I think a great place to invest it would be in seeds and seed quality, in improving the network and distribution of seeds. Seed counterfeiting still is a very significant problem. I think that there's a problem of modest sized farms are sometimes reluctant to invest in high quality seeds where their yield can absolutely increase, but we do still have this problem of counterfeit seeds. So there could be a nano/sensor solution to that kind of problem. I think there needs to be more investment in getting tools in the hands of farmers who make the decisions on the ground. I think that satellite technology has really been revolutionary, but there's a barrier beyond which you can't answer questions from that far up. There's some things about the plant or organism that you're going to have to get on a more local basis. There's been a lot of work done on hyperspectral, and I think we may have saturated on that. I think we say hyperspectral, but we mean hyperspectral reflectance. It's a way of monitoring crops. I think you're going to see the emergence of other hyperspectral modalities. So being able to learn things from plants on drones, but more than just the reflectance, but maybe other chemical information, that you can get. I still think that indoor farming or controlled environment farming is challenging. I think it doesn't scale well with rising energy costs, and it has to be done more thoughtfully in every different situation and market. Yeah, it's a complex problem.
I understand. I have one last question for you. If you had to pick one ag innovation or trend that you're most excited to see take off in the next 5 to 10 years, what would that be and why?
Well, I think I don't want your listeners to roll their eyes, but I really do think artificial intelligence applied to agriculture is going to be transformative. Of course, I'm going to say that, but no, I would argue that agriculture has a number of problems that are hard to describe deterministically. There are a lot of image-based and a lot of problems that could do well with sort of a classifier model. And I think that's true with a lot of areas of biology, but I also think that AI and the promises that it carries can help to speed up the digitalization of farming. And I think that in terms of technology, agriculture has lagged behind. the use of computational tools. And I think that the promise of AI will do not, I mean, if it does nothing else, it will just bring more automation and computation into this very important human enterprise that we've been doing, for at least 12,000 years, right? So I think we should have modern tools from this century used
A-
widespread. So hopefully, yeah.
a-
Right.
Absolutely, I agree. But Michael, thank you so much for joining us today and sharing your insights. And I'm excited to hear about the innovations and on the horizon and the possibilities they hold for the future of the ag market.
Okay, thank you.
Thanks for listening to Ag Tech Talk by AgriBusiness Global. Stay connected with the latest in ag tech and crop protection by following us on LinkedIn and visiting agribusinessglobal.com for more insights and updates. Until next time.